Tonight you fall asleep under a perfectly ordinary sky. You wake up, and nothing looks different. But 384,000 kilometers above your head, something the size of a continent has vanished. No explosion, no warning. The moon is simply gone. You wouldn't feel it happen, but your planet would already be changing in ways that would unfold over the next 100 million years. Most people assume losing the moon means the tides stop, the nights get pitch black, or Earth drifts off course. Almost none of that is the real story. The moon has been quietly running a piece of planetary machinery for over 4 billion years. One so important that without it, some scientists think complex life might never have had the stable stage it needed to evolve. To understand what we'd lose, you need to know where the moon came from. About 4.5 billion years ago, a Mars-sized planet called Theia slammed into the young molten Earth at an angle. The collision flung a ring of vaporized rock into orbit, which clumped together, almost instantly, in geological terms, into the moon. What makes our moon strange is its size. At about 1/81st the mass of Earth, it's disproportionately large compared to every other moon-planet pair in the solar system except Pluto and Charon. That size is exactly why it matters so much gravitationally. First myth to clear up. Without the moon, tides would stop completely. Not true. The sun also pulls on Earth's oceans. It's just farther away, so its pull is weaker. The moon supplies roughly 2/3 of our tidal force, the sun the rest. So tides wouldn't vanish. They'd shrink to about 1/3 of their current range. Dramatic tidal spots like the Bay of Fundy's 16-meter swings would collapse into gentle ripples. That sounds minor, but entire ecosystems, mangroves, tidal marshes, coral reefs, horseshoe crabs timing their spawning to specific tides, depend on that rhythm. Shrink the tides, and you starve the coastal food web. Next, no more moonlight. A surprising number of species use it to navigate, hunt, or breed. Coral colonies on the Great Barrier Reef synchronize a massive once-a-year spawning event to a specific full moon. Dung beetles use polarized moonlight to walk in straight lines. Remove the moon, and you remove a cue evolution spent hundreds of millions of years building around. Would it actually get pitch black at night, though? Less than you'd think. Full moonlight is only about 1/400,000th the brightness of daylight, so starlight and artificial light still carry us through. This part of the disaster is real, but it's not the big one. Here's the part that's genuinely alarming. Earth spins on a 23.4-degree tilt, which is why we have seasons, and that tilt has stayed remarkably stable for hundreds of millions of years. Most people assume that's just normal. It isn't. In 1993, astronomer Jacques Lascar calculated that this stability is almost entirely the moon's doing. Its gravity acts like a stabilizing hand, holding Earth's axis steady against the gravitational tug of the sun and other planets. Remove the moon, and Lascar's models show the tilt could start swinging chaotically by dozens of degrees over just a few million years, instead of today's tiny 2-degree wobble. For comparison, Mars, with only 2 negligible moons, has had its tilt swing wildly between roughly 0 and 60 degrees throughout its history. A shift like that on Earth would mean poles baking under direct sunlight for months, while the equator plunges into darkness, ice ages and heat extremes with no predictable pattern. This, not darker nights or weaker tides, is the real headline of a moonless Earth. The loss of the thing keeping our climate on rails. One more hidden mechanism. The moon's gravity also drags on Earth's spin, acting as a gentle brake that lengthens our day by about 1.7 milliseconds every century. In exchange, the moon steals that energy and drifts outward, currently receding about 3.8 centimeters a year, a rate we know precisely because Apollo astronauts left mirror panels on the surface that scientists still bounce lasers off today. If the moon vanished, that ancient braking system would simply switch off, freezing Earth's day length in place forever. A couple of strange extra details. Earth and the moon actually orbit a shared point of gravity, the Berry Center, which sits about 1,700 kilometers beneath Earth's surface, inside the planet itself. And the moon happens to be about 400 times smaller than the sun, but also 400 times closer, which is why the two appear the same size in our sky and why total solar eclipses are possible at all. Because the moon keeps drifting away, that coincidence is temporary. In roughly 600 million years, eclipses like this will end for good. Practically speaking, here's the fallout in order. Within days, coastal ecosystems dependent on strong tidal flushing would start stagnating, fisheries would suffer, and tidal power stations would lose most of their output. Within a few years, species relying on lunar breeding cues would see their cycles break down. Over millions of years, if Laskar's models hold, the axial tilt would begin drifting, bringing wilder, less predictable seasons and potentially extreme, patternless ice ages or heat periods. A few myths worth debunking directly. The moon does not meaningfully shield Earth from asteroid impacts. Its gravity is too weak, and it's too small a target. Earth's own gravity does far more of that work. Losing the moon also wouldn't fling Earth off its orbit. The sun's gravity, not the moon's, governs that path entirely. And despite folklore, full moons don't reliably cause strange human behavior. Large studies have found no real statistical link between lunar phases and crime or hospital admissions. So what would really happen if the moon disappeared? Not instant catastrophe, not darkness, not Earth spinning into the void, but the slow unraveling of a stability system that's run silently for 4.5 billion years. Weaker tides, starving coastlines, broken lunar cues, scrambling ecosystems, and eventually, the loss of the gravitational hand holding our climate steady. The moon isn't just a rock we admire at night. It's closer to a hidden gyroscope, quietly stabilizing the conditions that let life settle into the predictable rhythms it evolved around. So next time you look up at it, remember, you're looking at one of the reasons your world has stayed livable long enough for you to be here to see it.